Hey guys, this is Carrie, and this is the answer key video for homework number 13. So to solve this system of equations, I think because we got x squareds and y squareds, and because y is already isolated here, it's going to be best to substitute in for y using the substitution method. So this is going to give us x squared plus x minus 28 squared equals 400. Now, to simplify, we remember that when you have something squared, it's going to be that thing times itself. And these all give us 400. So you get x squared plus, to do this multiplication, we distribute x squared minus 28x minus 28x plus, off to the side on my calculator, 28 squared is 784, all equals 400. Combining like terms gives us 2x squared minus 56x plus 784 equals 400. This is looking pretty bad, but not really, because the structure of the problem is becoming evident. We've got an x squared and we've got an x. We'll probably need to factor. So I'm going to start by subtracting 400 to set it equal to 0. This gives us 2x squared minus 56x plus 384 equals 0. Next up, it would be impossible to factor with the 2 there, so we'll divide by 2 on both sides. This gives us x squared minus 28x plus 384 divided by 2 is 192, and that all equals 0. So they want us to factor this, and this is a pretty crazy sum and product problem. We're looking for two things that sum to negative 28 and have a product of 192. So how do we do this problem? Well, for factors of 192, let me try a couple that come to mind. I'll try to divide by 4, see if that works. It looks like we could do 4 and 48, but those aren't going to add to make negative 28. So let me try again. Maybe instead of 4 and 48, I could try it with 8 and something else. So 192 divided by 8, that gives me 24, so getting closer here, but that doesn't add to 28. Let me try with 12. So let's see, 192 divided by 12, that gives us 16, and that looks good. Even though these weren't factors that I knew of before, 12 and 16 do multiply to give us 192, and they do add to give us 28. So we'll get x minus 12 times x minus 16 equals 0. This gives us the two solutions, x equals 12 and x equals 16. But we're not done yet. With the system of equations, we need to solve for y. So we are going to plug these x values into our equations to find y. And I'm going to choose this equation here. Y is equal to 12 minus 28. So we get y equals negative 16. And here we get y is equal to 16 minus 28. Y is equal to negative 12. So it looks like the two solutions are 12 and negative 16. And 16 and negative 12. All right, so tough sum and product problem, but I think this emphasizes an important type of problem that we need to be able to solve, which is systems of equations with substitution. An angle theta is graphed in standard position. All right, whenever they say that, we should graph it in standard position. The terminal side passes through the point 2, negative 1. Find the exact value of sine of theta. All right, so let's see. I'll make the angle this. No, that's too similar. Red. So our angle is graphed in standard position, so it starts here and opens up here. I do that pretty sloppy, but I don't think it's going to affect us. Because the last thing to remember here is sine of theta is, let's see, using our coordinate plane formula is y over r. So it looks like we've got our y coordinate. We just need to calculate our r coordinate. To calculate r, we can think about this as a right triangle with side lengths 2 and 1, which means we can use the Pythagorean theorem to find r. So we get 2 squared plus 1 squared equals r squared, because that's the c value, from a squared plus b squared equals c squared. This gives us 4 plus Yep, I did the addition too fast. 4 plus 1 equals r squared. 5 equals r squared. R is equal to square root of 5. So, putting everything together, sine of theta is the y-coordinate, -1, over the r-coordinate, root 5. All done. Which function's graph has a period of 8 and reaches a maximum height of 1 if at least one full period is graphed? All right, so all of these have similar structure. They're all cosine functions. And these two should have the x value there, so I hope that typo doesn't throw you off. Sorry for leaving those off. One thing we learned is there's a big connection between the period of a function and its b value. So I'm actually going to start there. To find b, what we think about is when we plug in 8 to x, we want our graph to reach a full cycle. This means that b has to be, reducing by 2 on top and bottom, b has to be pi over 4. So we're able to eliminate choice 3 and choice 4 because these have the wrong b values. The b value should have been pi over 4. Now the next one up is to think about maximum heights. So for this one is a vertical shift of -3. Let me draw these a little separate, so I'll label them down here. So number 1, this one has a vertical shift of -3 from here, so the midline is at -3. This one has an amplitude of 4 because the -4 means it's going to go up 4 and down 4. 2, 3, 4. So it starts off 4 below, which is -7, and it goes 4 above, which is -2, -1, 0, 1. So here's one period for option 1, and that does have a maximum height of 1. Let's check what's up with option 2, though, because it had the right period. And let's see. So for option 2, this one has a midline of 5. And if its midline is 5, you can already tell right away the maximum height is definitely not going to be 1. However, we graph it in more detail. This means it's going to go up 4 and down 4, so it starts off at 1 and then goes up to 9. And it has the wrong maximum. For number 4, whoa, this one looks crazy, but it is a straight up algebra problem, so perhaps it's easier actually than a lot of the ones we have to do. So I see right here we should distribute. This gives us root 6 minus 2x plus x equals 2x plus 30 minus 9. Root 6 minus 2x is equal to, or plus x is equal to 2x plus 21. We subtract x on both sides. That gives us root 6 minus 2x is equal to x plus 21. Oh man, is this going to be another huge factoring problem? Let's see. We have to square both sides to get rid of the square root. Now that the square root has been isolated from the other pieces that started there. So this gives us 6 minus 2x is equal to x plus 21 times itself. 6 minus 2x is equal to x squared plus 21x plus 21x plus 441. Let me just confirm that on my calculator. 21 squared. Yep, 441. Okay. Adding 2x to get it equal to 0 and subtracting 6 to get it equal to 0 gives us x squared plus 21 plus 21 plus 2 is 44x minus, 441 minus 6 is 435 equals 0. So this is another beastly sum and product problem. Let's see if we can use the same strategy to solve this one. So this is going to be two numbers that add to 44 and multiply to 435. So thinking about 435, there's only one obvious number to me that divides it. Because it ends in 5, this number is divisible by 5. So let me hope that this one works. 435 divided by 5 is 87, and that does not work. 5 and 87 do not add to make 44. So I'm trying to think now what numbers would divide 435 other than 5. So let me try out 435 divided by 7. So if we try 7, the other number is a decimal, and that's not going to work. So 7's not the number. What about 9? So 435 divided by 9. That doesn't work either. That's a decimal. 435 divided by 11. I'm only trying odd numbers because I can tell no even number. Sorry. I can tell no even number will divide this number because it's odd. So 435 divided by 11 doesn't work. What about 435 divided by 13? Doesn't work. 435 divided by 15. All right, so this one has some promise. 435 divided by 15 gives us 15 and 29. And those numbers do add to 44. So it looks like our solutions are going to be x plus 29 and x plus 15. Those aren't our solutions. Our factors are going to be those, which means our solutions are x equals negative 29 and x equals negative 15. So what I like about this problem so far is that it illustrates that factoring doesn't have to be done correctly the first time. You can test dividing by different numbers. Now, each one of these solutions needs to be checked because when you have square roots, you can have extraneous solutions. So to validate them, let's test out x equals negative 29 first. What's important now is that you plug this into the original equation. So we get square root of 6 minus 2 times negative 29 plus negative 29 equals 2 times negative 29 plus 15 minus 9. I think I can tell that this one's not going to work, but let's see. So negative 2 times negative 29 is 58 plus 6, that's 64. Plus, let me simplify this. Adding a negative is the same as subtracting by 29. Oh, this one might work actually. 2 times negative 14 minus 9. This is 8 minus 29 equals negative 28 minus 9. And 8 minus 29 is negative 21. And over here we've got negative 28 minus 9 is negative 37. So these are not actually equal. So this is not a correct solution. Now you do have to check the other solution as well because you can't infer meaning from one check about the other. So this will be x equals negative 15 that we're checking. So let's plug that in. We get 6 minus 2 times negative 15 plus negative 15 equals 2 times negative 15 plus 15 minus 9. Negative 2 times negative 15 is 30, plus 6 is 36, so 36. Adding a negative here is the same as subtracting by 15 equals negative 15 plus 15 is 0. 2 times 0 is 0 equals negative 9. 6 minus 15 is negative 9. Negative 9 is negative 9, which is great because that does work. So this is our one solution to this problem, and the other is extraneous. One more short one to go, guys. So for problem number 5, find algebraically the zeros to this equation. So to find these, we would just factor it after setting it equal to 0 because we're looking for the zeros. Because we count 1, 2, 3, 4 terms, this is a factoring by grouping problem. So we split it into 2 parts. We get x squared times x plus 1 minus 4 times x, negative 4 times positive 1 to give us negative 4. And this is great news because we get x plus 1 and x plus 1. This gives us x plus 1 times x squared minus 4 equals 0. Many times factoring by grouping problems can be factored one more time, so x squared minus 4 can be factored using difference of squares. That gives us x plus 1 times x minus 2 times x plus 2 equals 0, which gives us 3 solutions. X equals negative 1, x equals 2, x equals negative 2, which is great because the highest power was 3 and we expect 3 solutions for the zeros of this polynomial. So we get negative 1 is a 0, 2 is a 0, and negative 2 is a 0. Now to figure out where the rest of the graph goes, I would graph it on my graphing calculator, and I'd graph it point by point to get some more points here. But I'm going to be sloppy and not use my graphing calculator. You should use your graphing calculator. It's going to be something like this when you do graph it. I don't know what exact... Oh no, that's not exactly it. I messed that up. It's going to be something like this when you do graph it. But you'll have to get a more exact graph than the one I just got because it's your regions, not mine. Bye guys, see you tomorrow in class.